Alright, so we've got this next video. It's about conditions for special parallelograms. And your learning target is I can prove that a given quadrilateral is a rectangle, a rhombus, or a square. Alright, so let's talk about some of the theorems about the conditions for rectangles, okay? So essentially, what makes a rectangle, alright? So the first one is if one angle of a parallelogram is a right angle. Okay, so remember, we've got all of the rules that apply, all of the conditions for parallelograms, and then one little extra thing is that if one angle of a parallelogram is a right angle, then the entire thing is a rectangle. Then we do have a rectangle, okay? The second thing, that if the diagonals of a parallelogram are congruent, okay, those two things on top of what makes up a parallelogram, those two things also apply to what makes up a rectangle. Now there's also some theorems about rhombuses, okay? About the conditions of rhombuses, okay? So if one pair of consecutive sides of a parallelogram are congruent, okay? So if one pair of consecutive sides, that means these two sides that lie right next to each other, if they are congruent to each other, and this is a parallelogram we're talking about, then we have a rhombus, okay? The second thing is that if the diagonals of a parallelogram are perpendicular, okay? If we find that the diagonals that connect the two opposite sides, or two opposite vertexes, if they combine to be perpendicular, then we have a rhombus. Okay, and the last condition is that if one diagonal of a parallelogram bisects a pair of opposite angles. Okay, so if the one diagonal bisects it, so we've got two angles that are exactly congruent, that are lying right next to each other, that will make a rhombus. So example 1 says that a manufacturer builds a mold for a desktop so that AB is congruent to CD. So let's just mark that real quick. That's talking about these two lines. A and B are going to be congruent with CD. And then we've got BC is congruent to DA. BC is congruent to DA. And that the measure of angle ABC, this little right angle right here, is 90 degrees. Okay, so it wants to know why must ABCD be a rectangle, and the first thing that we're going to put down here is that when you have AB, line AB is congruent to line CD, as well as BC being congruent to line DA, when those two things are true, that makes up a parallelogram, right? That makes it so that this is going to be a parallelogram. Okay, so we can say that makes it a parallelogram. So now that condition is already met. We know we have a parallelogram. Why must it be a rectangle? Because if we look back up at those theorems, it says, the very first one, it says that if one angle of a parallelogram, that made up the parallelogram, is a right angle, there's your right angle, then you have a rectangle, okay? So then because the measure of angle ABC is equal to 90 degrees and is a right angle, that makes it so that we have a rectangle. That's the part that really makes it a rectangle. That's the part that identifies it away as a special parallelogram. It's a special parallelogram then. So example 2 asks us to determine if the conclusion is valid. And if it isn't, then we need to tell what information is needed to make it valid. Okay, so in this part right here, we're given that EF, that's this line right here, is congruent to FG. So we've got these two sides are going to be congruent, as well as that EG, sorry, I moved the paper there, EG is perpendicular to FH. Okay, that means we're going to have a right angle here, right? We want to conclude that EFGH is a rhombus. And the first thing we need to do is, do we have enough information to even consider this a parallelogram? Okay, that's the very first place that we need to start. And if we look around here, remember, a parallelogram says that either the two opposite sides, the two pairs of opposite sides are congruent, and we don't know that. It says that It says that two opposite angles are congruent. We don't know that. It says that the angles bisect each other. We don't know that. Essentially, we don't have enough information to prove that this is a parallelogram, right? So we cannot conclude that this is a rhombus because even though the right angle here, the bisecting lines here that make it a right angle, we have to first know that it's a parallelogram, okay? So we can say, right now, we have to say that it's not valid. And the reason why it is not valid is because we need to know EFGH is a parallelogram. We need to know that EFGH is a parallelogram first. So essentially we need to know that GH, line GH and EH are also congruent to EF and FG. Okay, that's what we would need to know. Sorry, I wrote off the paper there. Okay, this second part right here, it says given that we have EB is congruent to BG. Okay, so we're going to have to kind of ignore these lines that we drew in a little bit ago. EB is congruent to BG, and FB is congruent to BH. Okay, right there, let's go ahead and mark this. This part right here, that makes it a parallelogram. Because those are congruent, that makes it a parallelogram. Okay, so it gives us more information now. It says that EG is congruent to FH. Okay, that part right there, because the two diagonals are congruent, that makes it a rectangle or square. And if we know that triangle EBF is congruent to triangle EBH, we know then that this side is going to be congruent to this side by that rule then, right? If those are two congruent triangles, then we know all the sides and all the angles are going to be congruent as well. So that last side has to be congruent as well as that. Okay, and so because we know that, because we know all this information, this part right here, this last part, says that we can make it a square. Okay, and so because of that, we can write that this is valid. That is valid. That is a valid way to conclude that EFGH is a square.